the complete Gen AI adoption framework, how enterprises move from AI experiments to secure, responsible, scalable transformation.
Hello and welcome. Generative AI is changing how organizations work, but successful adoption is not about launching random chatbots or experimenting with the newest model. It is about building a repeatable operating model that connects business value, data readiness, security, governance, responsible AI, architecture, operations, and measurable outcomes. The attached Microsoft Cloud Adoption Framework guidance explains AI adoption as a structured life cycle across AI strategy, AI plan, AI ready, govern AI, secure AI, and manage AI, with responsible AI principles applied across the entire journey. That structure matters because GenAI adoption touches people, processes, data, platforms, policies, and risk. Without a framework, organizations often move fast at the beginning, but struggle when pilots need to become trusted production systems.
The biggest reason Gen AI programs fail is that they begin with technology instead of business value. A strong adoption framework begins by identifying where the organization has real friction. This could be employees spending hours searching for information, customer service teams repeating the same answers, finance teams reviewing documents manually, developers writing boilerplate code, or analysts summarizing large volumes of reports. The goal is not to use AI everywhere. The goal is to focus AI where it can improve speed, quality, cost, customer experience, employee productivity, compliance, or decision making. Every GenAI use case should connect to a measurable business outcome before any model or tool is selected. AI strategy is the first major pillar of adoption. This means defining the business problem, the intended users, the expected value, the data required, the risk level, and the success metric. A customer support assistant might measure containment rate, response quality, customer satisfaction, and escalation reduction. An internal knowledge assistant might measure search time reduction, employee satisfaction, and answer accuracy. A document processing solution might measure processing time, error reduction, and compliance improvements. Strategy turns GenAI from a technology experiment into a business initiative. It also helps leaders decide which projects deserve funding, which should remain pilots, and which should not move forward. A complete GenAI strategy must also define the technology approach. Organizations usually have three main paths. The first path is ready-to-use AI, such as Microsoft 365 Copilot or role-based copilots, where the organization wants fast productivity gains with minimal engineering. The second path is platform-based AI, using tools such as Microsoft Foundry, Azure OpenAI, Azure AI Search, or Copilot Studio to build custom assistants, RAG applications, and agents. The third path is infrastructure-heavy AI, where organizations train, fine-tune, or run models on virtual machines, GPUs, Kubernetes, or high-performance computing environments. The best choice depends on customization needs, data sensitivity, compliance requirements, team skills, cost, and control. Many organizations should begin with copilots before building custom systems. Copilots can help employees summarize meetings, draft documents, search enterprise knowledge, create presentations, analyze information, and automate routine work. But even ready-to-use AI requires preparation. If enterprise permissions are poorly managed, AI can expose information too broadly. If content is outdated, AI can generate misleading answers. If employees are not trained, they may either overtrust or underuse the tool. Copilot adoption should include data classification, access reviews, user training, acceptable use policies, adoption metrics, and continuous feedback. Productivity AI is not just a software rollout, it is an organizational change program. Custom GenAI applications usually begin with retrieval augmented generation, often called RAG. RAG allows a generative model to answer questions using trusted enterprise data instead of relying only on the model's general training. A user asks a question, the system retrieves relevant content from approved sources, and the model generates a response grounded in that information. This pattern is valuable because it can improve accuracy, reduce hallucination risk, and keep enterprise knowledge under organizational control. But RAG is not simply connecting a model to a folder of documents. It requires data cleaning, chunking, indexing, embedding, search ranking, prompt design, access control, evaluation, monitoring, and governance. Data strategy is one of the most important parts of GenAI adoption. AI systems are only as useful as the data they can safely and accurately use. Organizations need to know where their data lives, who owns it, how sensitive it is, whether it is current,
whether it is legally usable, and whether it is suitable for AI grounding or training. Data must be classified, protected, governed, and monitored throughout its lifecycle. Microsoft Purview, data lineage, sensitivity labels, retention policies, and data loss prevention controls are examples of capabilities that support this foundation. Poor data governance creates poor AI outcomes even when the model is powerful. Responsible AI must be built into the framework from the beginning, not added after deployment. Responsible AI means the organization has a structured way to address privacy, security, reliability, safety, fairness, inclusiveness, transparency, and accountability. These principles need to become operating controls, review checkpoints, design requirements, and measurable indicators. For example, privacy becomes data minimization and access control. Reliability becomes test plans and monitoring. Transparency becomes user disclosure and explainability. Accountability becomes named owners and escalation path. Responsible AI is not a public relations statement. It is a governance discipline that protects customers, employees, the organization, and society. After strategy comes AI planning. Planning converts vision into a realistic roadmap. The organization should assess AI maturity, available skills, data readiness, technical infrastructure, budget, licensing, governance capability, and operational support. A team with limited AI experience should not begin with a high-risk autonomous agent that updates production systems. It should start with lower-risk internal use cases, copilots, or simple RAG pilots. A mature organization with strong cloud, data security, and machine learning practices can move into more advanced patterns. The roadmap should prioritize use cases based on business impact, feasibility, risk, and readiness. Skills planning is essential because GenAI adoption is multidisciplinary. It requires business leaders who understand process value, data owners who understand information quality, cloud architects who design secure environments, developers who build applications, security teams who evaluate threats, compliance teams who interpret regulations, UX designers who shape user interaction, and operations teams who monitor production systems. Organizations should build learning programs for AI literacy, responsible AI, prompt engineering, secure AI development, data engineering, RAG design, model evaluation, and AI operations. Some skills can be developed internally, while others may require hiring or partner support. Without skills, even good strategy becomes difficult to execute. Proofs of concept should be designed as learning vehicles, not as impressive demos. A good proof of concept validates whether the business problem is real, whether AI can improve the process, whether the data is usable, whether the response quality is acceptable, whether users trust the experience, whether security requirements can be met, and whether the solution can be operated at scale. The best early pilots are often internal, contained, and measurable. They should include clear entry criteria, exit criteria, risk controls, success metrics, and lessons learned. The result of a proof of concept should be a decision: stop, iterate, scale, or redesign. AI readiness is where the organization prepares the technical foundation for Azure environments. This includes landing zones, subscriptions, management groups, network boundaries, identity, policy enforcement, logging, monitoring, cost controls, and deployment automation. Internal AI workloads and internet-facing AI workloads should be separated so sensitive internal business data is not accidentally exposed to external users. Private endpoints, secure DNS, virtual networks, managed identities, Azure Bastion, API gateways, and policy-based restrictions help create a secure foundation. Readiness is not glamorous, but it is what allows AI systems to become production-grade rather than fragile experiments. Architecture decisions should match the use case. A simple employee productivity scenario may only need Microsoft 365 Copilot and data governance. A custom knowledge assistant may need Azure OpenAI or Microsoft Foundry, Azure AI Search, storage, vector indexing, and application layer, authentication, logging, and evaluation pipelines. A complex agent may need orchestration, tool integration, workflow triggers, memory, human approval, and runtime isolation. A custom model training workload may need GPU infrastructure, distributed storage, orchestration, and checkpointing. Good architecture avoids over-engineering, but it also avoids shortcuts that create security, reliability, or cost problems later. AI agents deserve special attention because they represent a major shift from answering questions to taking action. An agent uses a generative model to interpret inputs, reason through a task, decide what tools or knowledge to use, and produce an output or action. Productivity agents retrieve and summarize information. Action agents update records or trigger processes. Automation agents manage multi-step workflows with limited human intervention. The more autonomy an agent has, the more governance it needs. Agents require clear instructions, tool boundaries, identity controls, approval workflows, logging, testing, monitoring, and escalation rules. An agent without guardrails can become an operational risk. Governance is the operating system of GenAI adoption. It defines which AI systems are allowed, which models can be used, which data can be accessed, who approves deployments, how risks are assessed, how incidents are handled, and how performance is monitored. Governance should not block innovation unnecessarily. It should create clear guardrails so teams can move faster safely. Good governance includes an AI inventory, model approval processes, data usage policies, risk assessments, content safety rules, cost policies, deployment standards, regulatory compliance checks, and audit trails. Without governance, organizations often end up with shadow AI, duplicated tools, unmanaged costs, and hidden risk. AI risk management must be systematic. Each workload should be assessed for privacy risk, security risk, operational risk, fairness risk, legal risk, reputational risk, integration risk, and dependency risk. External dependencies, such as third-party models, APIs, open source libraries, and external datasets, should also be reviewed. A low-risk internal summarization tool does not need the same level of control as an AI system used in healthcare, finance, hiring, legal review, or public sector decision-making. Risk assessment should determine the required level of human oversight, testing, documentation, monitoring, and approval. The higher the impact, the stronger the controls. Security in GenAI adoption must address both traditional cloud security and AI-specific threats. Traditional controls include identity, network isolation, encryption, least privilege, logging, monitoring, vulnerability management, and incident response. AI-specific controls include prompt injection defenses, content filtering, model integrity checks, output monitoring, data loss prevention, adversarial testing, tool use restrictions, and red teaming. Attackers may try to manipulate prompts, extract sensitive information, poison retrieval data, abuse APIs, bypass filters, or make agents perform unauthorized actions. Secure GenAI requires a layered defense model because no single control is enough. Identity and access management are central to secure AI adoption. Users, applications, agents, models, tools, and data stores all need controlled access. Static keys should be minimized where possible, and managed identities or enterprise identity platforms should be used for service-to-service authentication. Role-based access control should follow least privilege. Administrative access should use just-in-time elevation and multi-factor authentication. Conditional access policies can add protections based on user risk, device compliance, location, and sign-in behavior. Access should be reviewed regularly because AI systems can magnify the impact of excessive permissions. Data security must protect both inputs and outputs. Sensitive data can enter AI systems through prompts, documents, databases, logs, training sets, retrieval indexes, or tool responses. It can also leak through generated outputs if controls are weak. Organizations need data boundaries between employee-facing, customer-facing, and public-facing AI applications. They need dataset isolation, encryption, private connectivity, classification, data loss prevention, retention rules, and monitoring. In RAG systems, indexing can unintentionally weaken source system permissions if not designed carefully. Every AI application should preserve the security model of the data it uses. Model governance is another essential layer. Organizations should know which models are deployed, where they are deployed, who owns them, what data they use, what risks they carry, what versions are active, and when they may be retired. Model selection should consider accuracy, latency, cost, context window, safety features, regional availability, compliance needs, and suitability for the task. Bigger models are not always better. Smaller models may be cheaper, faster, and sufficient for narrow tasks. Model governance should include approval policies, content safety controls, version tracking, retirement planning, rollback procedures, and performance monitoring. Cost management must be designed early because GenAI costs can grow quickly. Costs may come from licenses, tokens, model endpoints, embeddings, vector databases, storage, compute, networking, logging, fine-tuning, development time, and operational support. Token usage depends on prompt length, response length, grounding context, user behavior, and application design. Organizations should monitor tokens per minute, requests per minute, model usage, storage growth, and endpoint consumption. Cost controls can include quotas, budget alerts, model routing, prompt optimization, caching, batching, automatic shutdown for non-production resources, and gateway-based throttling. A Gen AI gateway can become a powerful enterprise control point. Instead of every application directly calling model endpoints, a gateway can centralize authentication, authorization, logging, monitoring, rate limits, content inspection, cost tracking, routing, and policy enforcement. It can route simple tasks to cheaper models and complex tasks to more capable models. It can apply circuit breakers during traffic spikes and provide audit trails for compliance. A gateway also helps standardize AI consumption across teams. This pattern is especially useful when multiple departments, applications, or agents are using shared AI services. Managing Gen AI in production requires continuous evaluation. Unlike traditional software, AI behavior can vary based on user prompts, data changes, model updates, and context. Teams should evaluate answer quality, groundedness, hallucination rate, latency, refusal behavior, toxicity, bias, safety, and user satisfaction. Golden datasets can help test whether a model or RAG system continues to perform as expected. Human feedback should be collected and reviewed. Automated evaluations can detect regressions before they reach users. Production AI should never be treated as finished. It must be measured, improved, and governed continuously. GenAIOps and MLOps provide the operating practices for AI lifecycle management. MLOps focuses on traditional machine learning workflows such as training, validation, deployment, monitoring, and retraining. GenAIOps focuses on generative AI patterns such as prompt management, RAG pipelines, model endpoint management, grounding data evaluation, safety testing, and feedback loops. Both require version control, CI/CD pipelines, automated testing, environment separation, release approvals, observability, rollback capability, and documentation. These practices turn AI development into an engineering discipline rather than a collection of manual experiments.
Business continuity is often overlooked in AI adoption. If an AI system becomes part of customer service, operations, development, or employee productivity, downtime becomes a business problem. Organizations should plan for regional outages, model endpoint failures, quota limits, data store failures, corrupted indexes, and degraded model performance. Critical AI assets such as prompts, model configurations, datasets, embeddings, indexes, fine-tuned models, and application code should be backed up and versioned. Multi-region deployment, failover routing, disaster recovery testing, and documented runbooks help ensure AI services remain reliable when disruption occurs.
The AI Center of Excellence can help coordinate adoption across the organization. Early in the journey, the Center of Excellence may define standards, review use cases, build reusable templates, support pilots, guide responsible AI practices, and help teams choose the right technologies. It should include business, technology, data security, risk, compliance, and operations expertise. As adoption matures, the Center of Excellence should evolve from a centralized gatekeeper into an advisory model. The goal is to distribute AI capability across teams while keeping common standards, governance, and security practices consistent. Organizational change management is just as important as technology. Employees need to understand what GenAI can do, what it cannot do, when to trust it, when to verify it, and how to use it responsibly. Leaders need to communicate that AI is not simply a replacement tool, but a productivity and transformation capability that changes workflows. Adoption programs should include training, role-based guidance, prompt examples, office hours, champions, feedback channels, and success stories. If users do not trust the system, they will not use it. If users over-trust the system, they may create risk. Balanced adoption requires education and culture. Measuring GenAI value requires both business and technical metrics. Business metrics might include time saved, cost reduction, revenue impact, customer satisfaction, employee satisfaction, faster cycle times, reduced backlog, improved compliance, or better decision quality. Technical metrics might include latency, uptime, response quality, groundedness, token usage, error rates, escalation rates, safety filter events, and model drift. Responsible AI metrics may include fairness checks, transparency reviews, accessibility feedback, and incident tracking. Measurement should begin during the pilot and continue after production.
What gets measured becomes manageable, and what is not measured becomes guesswork. A practical GenAI adoption roadmap usually moves through several phases. The first phase is discovery, where the organization identifies use cases and defines strategy. The second phase is readiness, where data, security, identity, governance, and architecture foundations are prepared. The third phase is pilot execution, where control proofs of concept validate value and risk. The fourth phase is production, where the solution is deployed with monitoring, support, and controls. The fifth phase is scaling, where reusable patterns, governance, automation, and training allow multiple teams to adopt AI safely. The final phase is continuous improvement, because AI systems evolve over time. The most important lesson is that GenAI adoption is not a single project. It is a new enterprise capability. Successful organizations will not be the ones that simply adopt the most AI tools. They will be the ones that connect AI to business outcomes, prepare their data, choose the right technology, secure their systems, govern responsibly, manage costs, monitor quality, and help people change the way they work. GenAI can transform productivity, customer experience, software development, operations, and decision-making. But transformation only becomes sustainable when it is built on trust, discipline, and a repeatable adoption framework. Thank you for watching.